Hello students, I hope you're having a wonderful day. Today I would like to complete a practice problem that covers the law of conservation of momentum in 2 dimensions. So I'm going to read the problem, we're going to draw a diagram, and then we're going to solve for the answers. So let's go ahead and get started. A 1,345 kilogram car moving east at 15.7 meters per second collides with a 1,923 kilogram car moving north. The two cars stick together and move with a velocity of 14.5 meters per second at 63.5 degrees after the collision. So we have 3 things to take care of today. In part A, we're going to calculate the initial momentum of the car moving north. So we're going to identify this with lowercase p. Remember, lowercase p identifies momentum. So P sub I sub north. Next, we're going to calculate the initial velocity of the car moving north. And then in part C, we are going to identify if the car moving north was exceeding the speed limit of 60 kilometers per hour. So the first thing that we need to do is go ahead and draw a diagram. So initially we have a car moving east. So the mass of the car moving east, so I'm going to say m sub east is equal to 1,345 kilograms, and the initial velocity is 15.7 meters per second. So I'm going to use the subscript again of east. So the initial velocity of the vehicle moving east is 15.7 meters per second. Okay? Next, we have a car moving north, has a mass of 1,923 kilograms. So mass of the car moving north. So to keep things straight, I'm going to use a subscript of north. So this is going to be 1,923 kilograms. Okay, the two cars stick together and move with a velocity of 14.5 meters per second at 63.5 degrees after the collision. So what we're going to end up doing is using the law of conservation of momentum here. Now remember that it states that the initial momentum of the system is equal to the final momentum of the system after the event. So momentum is conserved here. So the event in this situation is the collision of the two vehicles. So I placed a point here, the point where the two vehicles collide, and I'll just put a note here. So my note is collision, because the collision is the event. Now the problem tells us that the cars stick together and slide at 63.5 degrees. Okay. So my angle theta, 63.5 degrees. Okay. And we first have to calculate the initial momentum for the object moving north. Okay, so I need to add a piece of information here. So the final velocity of the system is equal to 14.5 meters per second. And the first step to calculating our our initial momentum for the car moving north is to calculate the final momentum of the system. So I'm going to identify that right here. P sub F sub system. Now, to calculate the final momentum of the system, this is going to be the product of the total mass of the system and the final velocity of the system. Okay? Now, we don't know total mass right now. We're going to have to calculate that. It's just the sum of the mass of the vehicle moving north and the vehicle moving east. So what we have is mass of the vehicle moving north, 1,923 kilograms, plus mass of the vehicle moving east, 1,345 kilograms, times the final velocity of the system. Right here it was given to us in the problem. Okay, 14.5 meters per second. All right, so we're first going to have to add our two masses. So 1923 plus 1345. This will give us 3,268 kilograms times our velocity, final velocity of the system is 14.5 meters per second. So we're going to multiply our total mass by that final velocity. And that gives us 47,386. And the units for momentum are kilogram meters per second. So this is the final momentum of the system. I'm going to put a dotted box around this because we're going to need this value here in a minute, okay? So what I want to do is I want to draw the vectors, draw our initial momentum vectors on the right side of our diagram, okay? So what we need to do is identify our initial momentum, so P sub I, and I'm going to use the subscript of east to stay consistent here. And what we're doing is adding vectors graphically. So we're going to place the tail of vector 2 on the head of vector 1. So I'm going to place the tail of our initial momentum vector for the car moving north on the head of the initial momentum vector for the car moving east. So we have the tail, and then right up here we're going to have the head. This is going to be the initial momentum for the car moving north. Okay? All right, so we have a right triangle here, and we have an angle of 63.5 degrees here. So to calculate the initial momentum for the car moving north, we need to calculate this value. So we're going to use the base trigonometric function sine. Sine theta is equal to the opposite side length divided by the hypotenuse. So I'm going to apply this base equation to our situation. So I've got sine theta is equal to the opposite side length with respect to angle theta. Boom, this guy right here. This is the initial momentum of the car moving north. So P sub I sub north. We're going to divide this by the hypotenuse value. So here we have the hypotenuse, and the initial momentum of our, the final momentum of our system, that's this vector here. This is our hypotenuse. We've calculated it, 47,000. Well, final momentum of the system. So what we're going to do is isolate this value. And we're going to do that by multiplying both sides of the equal sign by the final momentum of the system. So on the right side of the equal sign, final momentum of the system cancels. And so what we have is the initial momentum for the car moving north is equal to the final momentum of the system, 47,386 kilogram meters per second, times sine of the angle theta. Angle theta is given to us 63.5 degrees. Okay, so let's grab our calculator here. And that will give us 42,407.359 kilogram meters per second. So what I want to do is go ahead and write that answer up here for A. So the initial momentum for the car moving north, 42,407.359. And we have units of kilogram times meters per second. Okay? Next, in part B, it wants us to calculate the initial velocity of the car moving north, okay? I'm going to erase this business here to free up some room. So we know the initial momentum for the car moving north. To calculate this, now we already have the value here, but to calculate this, this is going to be the product of the mass of the car moving north and its initial velocity. Okay? So we know the initial momentum, we know the mass of the vehicle, and we're going to calculate the initial velocity of the car. So what I'm going to do is isolate this value by dividing by the mass of the vehicle moving north on both sides of the equal sign. This will give us initial velocity of the car moving north is equal to the initial momentum of the car moving north divided by the mass of the vehicle moving north. Okay? So what I'm going to do is just plug in some values. So we're going to use the calculated value for the initial momentum. This is 42,407.359 kilogram meters per second, and we are dividing by mass of the car moving north, which is right here, 1,923 kilograms. So first, what I want to do is take care of the numerical value, okay? So what we have is 42,407.359. We're going to divide by 1,923 kilograms. And this will give us initial velocity moving north, 22.052. Now let's take a look at our unit value. So right here in the numerator we have kilogram meter per second, and we're dividing by kilograms. And algebraically, we know that this is kilograms over 1. And whenever we divide fractions, it's like multiplying by the reciprocal of the denominator. So this will give me kilogram meters per second times 1 over kilogram. You can see that units of kilograms will cancel, leaving us with units of meters per second. So the initial velocity of the car, so right before the collision, is 22.052 meters per second. What let's do is write that down over here for our answer. And then in part C, it wants us to identify, was the car moving north exceeding the 60 kilometers per hour speed limit? Well, we've identified the initial velocity in units of meters per second. So now what we need to do is use dimensional analysis to convert from meters per second to kilometers per hour. So we know that we have 1,000 meters in 1 kilometer. So here I've got meters in my numerator, meters in my denominator. Boom, those guys cancel. Next, we're going to multiply by 3,600 seconds divided by 1 hour. So seconds in the numerator, and then I've got seconds in the denominator. Those guys cancel. So we have 22.052. We're going to divide this by 1,000 and then multiply it by 3,600. And the velocity of the car moving north before the collision is equal to 79.387 kilometers per hour. So, in part C, it wants to know, was the car moving north exceeding the 60 kilometer per hour speed limit? And right here, speed limit 60 kilometers per hour. This vehicle was traveling a little bit over 79 kilometers per hour. So, the answer is yes. The car traveling north was speeding. Okay. All right. Well, I hope this has helped you today. As always, if you have any questions, you can send me an email, you can contact me over Canvas, or you can give me a call. All right. Thank you, and I hope you have a great day.